Hello everyone, I'm back after, way too long of a break. Anyway, I'm planning to start releasing YouTube videos more regularly now. So, what do you know about getting the position of the mouse when it is outside of the stage? Well, if you've seen my latest project, then you definitely know you can. But how? Well, today I'm going to show you how I made this extended mouse position project, plus I'll show you how to turn it into an easily accessible module that you can use in any of your projects. So like, subscribe, open up Scratch, and then we'll get scratching. Okay, so first things first, we need a way to sense the mouse pointer when it's outside of the stage. I mean, that's pretty obvious. We could try using the point towards and distance block to triangulate the position of the mouse pointer. Or can we? Well, unfortunately, no, because Scratch clamps the mouse pointer to inside the stage before calculating the distance and direction. So throw that out of the window. So what blocks can you use? Well, pretty much the only block that you can is... Where did it go? Oh, here it is. The touching mouse pointer block. This block works even when the mouse pointer is outside of the stage, so it is very useful when getting the position of the mouse. So the basic concept of getting the mouse position is to keep moving a box until it hits the mouse pointer. Then you can just get the position based off of that. So first, we're going to need a box. So go over to the costume editor and draw a box. No, do not just draw any box. Use the box tool to make a box for you. Make sure it's pretty big and drag the box so the right edge of it is snapped to the center of the costume. Turbo Warp makes this easy and automatically snaps it. If you don't have Turbo Warp, well then, too bad. Now you'll have to watch my whole other video on how to set up Turbo Warp with my preferences. Okay, so now that we got our box made, we can start programming. Okay, so first we're going to need to create some variables. First, just delete this standard variable because it's a nuisance, it always gets in your way. So we're going to make a variable called eMouse for extended mouse. Then we're going to do -x. Then we're going to hit OK. And then we're going to make another one for y. Okay, so now that we got our variables created, we can program. So we're going to go when green flag clicked, forever, go to 0, 0, then repeat until touching mouse pointer, move 10 steps. So now we can run this, and as you can see, it will move until it's touching the mouse pointer, then go back. So now at the end of our script, we can set the eMouse X to the X position of our sprite, and that will now give us the position of the mouse. Now this right here is still very slow and chunky, so to speed it up, we can put it in a custom block with the run without screen refresh enabled. So now if we run it, you can see that it is now fast, but still chunky. So to fix that, we can easily change the move 10 steps block to only move 1 step. But for now, we're going to want to turn the run without screen refresh off so we know what's going on. Okay, so currently this only works if the mouse is on the right side of the stage. So to make this work for both sides of the stage, we'll have to rotate the box depending where the mouse is. If it's on the left side, we want it to point left, and if it's on the right, we want it to point right. So in Scratch, if you put any triangular-ended blocks into a number input, true will get converted to 1, and false will get converted to 0. So using this, we can set the rotation to mouse x less than 0 times -180 plus 90. This will make it if the mouse x is greater than 0, then it will set the rotation to 90. If mouse x is less than 0, it will set the rotation to -90. So now if we run this, it should work for both sides. Now, of course, if we move too far off the stage, Scratch's annoying fencing will get in the way. So to get around the fencing, the easiest way is just to set the size to a very big number, like 20,000. Now, just doing this won't work either, because Scratch's annoying fencing will get in the way again. So to get around this, we need another costume that's blank. So go over to the costume editor again and create a blank costume. So the default blank costume in Scratch is actually not blank. It is 2 by 2 pixels big, so we don't want that. We want a 0 by 0 pixel costume. So to do that, you can just draw something and then delete it, and it will automatically reset it to 0 by 0 pixels. Okay, so now name this to blank and rename the other one to box, just so we know which is which. Then we can switch to the blank costume, set the size to 200,000. Then we can switch back to the box costume, and this gets around Scratch's fencing. So now that we got our scan X block created, we can now make the scan Y block. So create a block named scan Y, and then duplicate the script in the X block, and change all of these to Y. Then remove the plus 90 from the point and direction block, because we want this to be up and down, not left and right. Okay, now just add the scan Y block to the end of our forever loop, and when we run it, the mouse X and mouse Y should now display correctly. Now it's tempting to stop here, but no, we are not at all done. This 30 blocks of code is by no means efficient, because you can see if I move my mouse too far off the stage, it will get very laggy. So to make it more efficient, we need to add 83 more blocks. Yes, 83 more blocks. Higher block count does not always mean slower, and for this case, it's actually the opposite. It's a lot faster. So for the first step of making this more efficient, we can remove these two go to 0, 0 blocks. Removing these will speed it up by a lot, because now I'll check for the mouse position starting from where the mouse was on the previous frame. This works good until we move the mouse back in the other direction, because now it will say we stopped. The reason for this is because it's already touching the mouse. So to fix this, we need to duplicate these repeat until scripts and make them repeat until not touching mouse, and then change this to -1. So now this will make our script move the box forward until it hits the mouse, and then backwards until it doesn't hit the mouse anymore. So now if we run this again, you can see that it now works perfectly and is a lot more efficient. But still, if you were to jerk your mouse very fast, it can still be laggy, because the sprite has to move over a big amount, so we need to fix that. But before we do anything else, we want to clean up our code a little bit. Because as you can see, these two scripts are identical, so we want to put them into one block. So create a new block called scanned, and then drag both of the repeat untils into there. Then replace them with the scan block. That'll just make things easier later on when we want to change that script. So I just noticed that in Scratch, it doesn't get the correct position due to some funny rounding that Scratch has and TurboWarp doesn't when scaling your sprite. So we definitely need to fix that, but we can do that later. So make sure to stick around to the end of the video so you can make it work properly in Scratch. Okay, so to fix this from lagging when we jerk our mouse pointer, we're going to want to make our scan script more efficient. So instead of taking teeny little steps until we touch the mouse pointer, we're going to want to take big steps. And then once we touch the mouse pointer, we're going to divide the step amount in half and move in the opposite direction until we are no longer touching the mouse. Then we divide again and go until touching the mouse pointer and so on until we're only moving one step. Okay, so we're going to create another variable called _step length, then remove the repeat untils from the scan block. Then at the start of it, we're going to want to set the step length to whatever we want the initial value of the step size to be, which in this case, 256 should be a big enough value. Now we're going to do repeat until ABS of step length is less than 1. And for any of you who do not know what ABS is, it stands for absolute. And if any of you don't know what absolute means, it basically just turns any negative numbers positive. Okay, so now inside the repeat until loop, we are going to move by the step length. Then if the step length is greater than 0, meaning that we're moving forward, we will check if we are touching the mouse pointer. And if we are, then we're going to set the step length to itself divided by -2. This will make it move backwards with more precision. Now else, if the step length is less than 0, we can check if it's not touching the mouse pointer, and if it is, then we need to do the same thing as up here and set the step length to itself divided by -2. Now this should move by the step length until it touches the mouse, then it will go in the other direction twice as slow until it's not touching the mouse, flip directions, and keep doing this until we're only moving one step. Even though this sounds a lot more inefficient than the other script, the script only has to move the box a few times before finding the position of the mouse, as the old one would have to move it hundreds of times before touching the mouse pointer, making this new scan script a lot more efficient. Right now, this script is kind of dangerous because if you were to accidentally change the costume to the blank costume, it would freeze the editor. So just to make sure this doesn't happen, we're going to check if the script has run over 1,024 times. And if it has, then stop it, because obviously it didn't and probably won't touch the mouse pointer anytime soon. Then just over here, reset the position to 0 if it had ran that many times. So now if you switch to a blank costume, it won't just freeze, but it'll just set the position to 0 instead. Okay, so now it's time to fix that Scratch bug. So let's go to their GitHub, find where the problem is in the code, fix it. No, that is way too complicated for this tutorial. So we'll just have to fix this in Scratch. Okay, so first we need to create an offset variable. Then at startup, we can set this variable to 0, call the scanx block, then set the offset to emousex minus mousex, and this will calculate the value that we need to move ours by to get the right position. So now at the end of our scan block, we can just move by our offset, and if we open this up in Scratch, it should now work perfectly fine. Now this works fine unless the user jerks their mouse pointer outside of the stage while they're clicking the green flag, and then it'll get all messed up. So to fix this, we need to wait until we know that the user's mouse is inside the stage, then we can calculate the offset. So to do that, we're going to say wait until ABS of mouse X is less than 240, which is half the width of the stage, calculate the offset, then start updating the mouse position. Now when we jerk the mouse when clicking the flag, it will wait until the mouse is inside the stage before calculating the offset. And actually, this won't work if you jerk the mouse to the right, so we're going to have to put an ABS there, and that will fix the problem. Now this works good, but we can make this a little better by checking both the X and Y instead of just checking the X. So we'll need an OR block, and we're going to have to drag that into there, put that back into there. They're going to want to duplicate this and then change this to mouse Y, and then we're going to want to change this to 180 because that's half the height of the stage. So then we can need an if block, an if else block, and put that there, drag the forever loop back out, and then we're going to want to duplicate this and change this to scan Y, and change this to eMouse Y, and this to mouse Y. Now the very last thing to make this more efficient is in the forever loop. If the mouse is already in the stage, then just get the mouse position from the mouse blocks instead of scanning for it. Okay, so now we should have pretty much a fully working extended mouse position sprite. But there's still one more thing we can do to make this easier to use in any of your projects. We need to modularize it, which means turn this into a module. A module in Scratch is basically a sprite with no hat blocks other than the when I receive hat block. You can think of these messages as custom blocks that you can run in another sprite. So to modularize this, first we'll want to rename the sprite to eMouse, which stands for extended mouse. Then we're going to replace the when green flag clicked with a when I receive block, and we're going to make a new message called eMouse, the name of our module, then -start. Then we're going to drag everything inside the forever loop into another when I receive called eMouse-update. Modularizing this makes it really simple when wanting to use this in another project. All we have to do is just drag in the eMouse sprite, and then when flag clicked, broadcast eMouse start, then forever broadcast eMouse update. So yeah, just to polish this thing up a little bit, we can rename these blocks to get extended mouse X and get extended mouse Y. And then the update loop, we're going to want to check if the offset has been set or not. And if it hasn't, we want to stop the script because otherwise it could give the user a wrong value. And also a little tip, if you have an if-else at the end of a block or broadcast, it's more efficient just to say if, and then the last thing inside the if, you want to say stop the script. And then the stuff that was in the else, you're going to want to put that outside at the end of the if. And also, we just want to clear the variables at the start just so no weird things will happen. Oh, and one very important step. Hide the sprite and turn on run without screen refresh on all of these blocks. Yeah, that's pretty much it. You should now have a fully functional extended mouse position module that you can easily use in any of your projects. If you have any questions, problems, or ideas for future tutorials, make sure to like, subscribe, comment, and I'll see you in the next one.
Okay, wait, it's already August 7th?